Good afternoon. Am I audible to you guys? Am I audible?
Yes, ma'am.
Okay, so today we will see the program for linked list. I'll give you guys the program for the linked list, and you guys can just go to programming lab and check whether the program is working well or not. Apart from that, you can just check each and every line of the program because this program is a bit long. Then you can just check whether you are understanding everything or not. Okay, so to understand the program for linked list, you have to remember your class from structures. Okay, we start. A programming lab is available there, means even if the software is not installed, you can use online compiler because there are lots of exams always. They conduct exams in the programming lab, and sometimes they just remove all pre-installed software. So it is possible maybe software is not available right now, but anyways you can try the online compiler for C. Hopefully the software they will be already there, like CodeBlock or DaveC, because last time you guys did there. So okay, let me come to the concept. Can you see the whiteboard?
Yes, ma'am.
Okay, so what happens in a linked list? Okay, I guess the concept is clear to you guys, how we can add and how we delete in linked list. So in linked list everything is a node. It's not linear data structure. It just nodes, and it can be just stored anywhere in the memory block. So in linked list we have, in the node we have two fields. One is the data and one is the pointer to the next node. Okay, pointer to the next node, or we can also say address of the next node. Okay, so if this is a node for linked list, so what type of data structure we can use? Means is it easier to use linked list? Means what type of variable we can use? We cannot use array here, right? The whole point of using linked list is that in linked list we can allocate memory dynamically. Then in array we always have to specify some space and all. Correct. So, and moreover here we need to maintain two things. One is the data part and one is the pointer part. So which one will be the easiest data structure? User defined variable. Remember the variable. What are the user defined variable? We have already predefined variable. So we had variables which we can define ourselves, right? Some are just predefined and some are user defined variables. So what are the user defined variables? Structure and union. Structure is the variable where we can just define different types of data types, right? So to implement the linked list, you have to remember your structure. Okay, structure data type you need to remember, so you can just brush up your previous classes uh, in structure. So what we can do here is how to define, for example, struct node. Okay, it is a uh, your structure node. So you need to define two things. it's a node, we need to define the data part, and we also need to define the next pointer. So how we can do it? Any guesses? For example, your data type is integer type. So what you are going to do? See, if you decide that all data will be integer type, obviously your data will be of int type, correct? And if you want to store floating type variables values, then you have to write float. Okay, for the time being, just think we are going to store just in variables. Okay, in data types means values. So you have to define a variable like this in data. Okay, then there's another part in your node which is a pointer. Okay, so what is this pointer? This pointer will give you the address of the next node. So obviously it will be another struct node because I'm just defining all nodes as struct node. So it will be a struct node again, but it will be basically a pointer to your next node. Okay, that's how we can define any node in your linked list. Okay, that's the important part. Okay, so after that, what? After that, as you already know, we can add or delete item from anywhere. We can add in front, or we can add or delete from front or at the end, or we can just do operations in random place. Okay, so this is mainly the node of a linked list. Struct node, in data, and structure node to the next pointer. It's basically pointer to the next. That means address of the next node. And in data types is for the data part. If you want floating point, you can just change the data type. Okay, but in normal way, we just use in data. Okay, but it's up to you what type of data you want to. So it will be mainly application based. Okay, got this part? This is a node for the linked list. Okay, let's go to the program part directly. I guess the basic concept to add and delete item is clear for everyone. Yes, no? In the morning class, how we can add, how we can delete. Stop sharing this one, go to the program part. So can you see the program? Can you see the program in the screen? Yes, no, anything? Can you see the program console? Can you see the program console? Are you guys listening? Am I audible? Hello? Am I audible? Then you have to respond, right? I'm asking you guys question whether you guys seeing the console or not. Can you see the screen? Can you see the program in the screen? Is it visible?
Yes, ma'am.
Okay. So in this program, first we are just defining the node for the linked list. Okay, the same thing I just explained right now. It's a node, then the data part, it will be integer type, then the pointer will be structured node and the next pointer. Next, we call another variable. So we just name this variable as the head. We also need to maintain the head pointer, right? Head will consist of the address of the next node, means first node. Okay, so this is the defining part for the node. It will be a global variable. Then we are also defining another structure node, which is the head. From the head, we will know which node is the first node. Okay, then after that, we just defined um, different functions to insert at the beginning, then insert at the last, then in random location. Then similarly for delete also, we can delete from the front or last or any specified location. And we can also search for the items and then show. Okay, so here since we have 9 options, I'm giving the condition till it's not equal to 9. Means once the 9 is done, then default value will be show like invalid choice. So main things comes here. So what happening in the begin in insert? So since you have already defined the node as the global variable, that means you can use this node directly in any of your function. So here you are just using the pointer variable pointer and the item you want to add. Okay, so as you guys know, linked list is a dynamic memory allocation. So here you are using a malloc function. So this is the main structure of your dynamic allocation program for the malloc. So what we do in malloc place, we just define what should be the size. So we already defined the structure node. So I'm just saying the size, the amount of memory location should be the same as the size of the structure node. Then we are just defining that value to the new node, structure node. Okay, then here we are checking whether pointer is null. Pointer null means is the last one, then it will show overflow. Okay, now question comes, why we are checking the overflow condition here? Because I mentioned linked list is a dynamic memory allocation. So we mainly check overflow condition in stack and queue or even in array. But since linked list is like dynamic one, so what's the point of checking the overflow condition? Anyone wants to answer? Wants to answer? Why we need to check the overflow condition here? If you cannot answer, then you can just say no. But just think for a while. Why? See, even if it's dynamic 1, still we need to allocate some memory in the main memory, right? So if you keep allocating some memory, your main memory can exhaust too. Therefore, here also we check the overflow condition. Okay, because in case of stack and queue, we are mainly concerned about the size of the stack and queue, then we check the overflow. But here mainly we check the overflow condition because it can exhaust the main memory. Okay, anyway, we just allocate some memory in the main. So here, after checking the overflow condition, if it is not applicable, then we enter the value. So how we enter the value? We just storing the value at the item. Now remember this arrow we use to access any member from a structure variable. So here just setting the pointer for the item and also accessing the value from the head. Remember here I have two things, head and this next pointer is for the address to the next, and for another pointer I'm using the head pointer. Okay, so after that I'm accessing the value of this only. Okay. Beginning insert, yeah. So after that the head will be the pointer. Means at the beginning what we do, we simply set the item. The item will be just data, then we check, mainly we replace the value of the header, right? Header consists of the address of the first node. So here we are just replacing, accessing the value from the head. That means the next is there. In the head, if there is nothing, it will simply set the value of the first node at the header. Then we will just set head equal to pointer. Okay, so node will be inserted. Now if you want to add item or any data into the last, what we do, same process, rest is just same. In case of last node, what we are concerned, we are only concerned about the last node pointer. If it is a last node, the pointer or address specifies the null. Okay, so here we are doing the same thing. So we are adding the item. Now we are checking if head equal to null. That means, for example, there is only one item in the linked list. One node is there. So if head equal to null, then we will simply put that next will be the null. Okay, then head pointer will be set. So the node will be inserted. Else means if head is not equal to null, that means something is already inside your linked list. So we will simply set it in a temporary variable head. So if while next is not null, it's just the value you are accessing, see everything, the part in the next, and this is the pointer. So we can access pointer values using this operator only. So we are checking whether that next is equal to null or not. If it is not null, then we are simply setting the next pointer to be the null and your node is inserted. Okay. And for the random insert, same process again, checking overflow condition. Just you have to select the location where you want to add item. So once you select the location, maybe third or fourth, then you will just go to just before that node and you will again use the temporary variable and keep your next node here. Okay, if it's not fulfilling the condition, it will simply say can't insert. Maybe there is only one node there, then in that case you cannot just select in the middle, right, the location whatever you inserted. Okay, then if it is a valid location, you will simply change the pointer variables. You are simply change the pointer variables. You need to change the pointer variables, like that's why you are just using a temporary variable here. So after that node will be inserted. It's you just need to follow the concept I explained you in the first class. Okay, it's just same. All you are doing is that you are accessing the value of the pointer Okay, and you are changing only the pointer part. That means the address part. You are not touching the data part. Mainly you are doing all adjustment in the pointer part, which is the address part. Okay, again for delete also, you are just first checking whether it is empty or not. Otherwise, you are just deleting. How to delete it from the beginning? Simple. You just need to remove whatever is set in the head part. Okay, and you set the head part to be the address of the next node. Okay, so first node will be deleted. From the last one also is same. You are concerned about null part. So here you are checking if head equal to null or not. If it is not null, then you will simply set head equal to null. That means there was only one node and you have deleted the node, so head will become the null. Okay, then after that you are just freeing the head. That means there is only one node of the list which has been deleted. Else if there is other nodes are there too, you are checking the next pointer is null or not. If not, you are simply setting the next pointer for the next node. And rest is also same. For the display is same. For random location also, just like your adding items. Deleting also same. Okay, so let's run this program. Enter your choice, insert beginning, enter value 3. So I just inserted one node. Let's one more item, 5, let's say 8 show. So there is two items only, 5 and 3 there. Now I want to delete. Now I want to insert item at the last. So I select 2, enter values 8. So it's added. So if you want to show again, see, it's added at the last part only. Okay, I added 7 and which has been appended at the last. Okay, if you want to select set in a random location, maybe 3, and to enter choice 3, enter the value 7, enter the location where you want to select, maybe 2. Okay, now show 8. Okay, so I selected the last position 0, 1, 2, so it is appended there. Okay, and to add some more random location 8. Okay, so 24 added there. So if you want to delete some item, delete from the back. Okay, it just got. Okay, so I deleted only one node of the list is deleted. Okay, that's if you want to delete from the beginning, enter your choice. I added one more, 56, 8. Okay, only 56 is there. So I deleted previous one. Now I just added 56 here. Okay. So I'll share you this program. You guys go to the programming lab and implement it. See whether you are getting the correct results or not. Okay. And also try to understand each and every line. This program is not like the previous one where you are using array. Here using structure. So to remember the structure, you just go through your structure class. Okay. Stop sharing. And just remember the concept of adding and deleting items in linked list. Okay. I hope it is clear to you guys from the morning class. Okay. So I'll end the meeting now. I'll share the program in the group and you guys go to the lab. Lab assistant will help you guys. If you find any problem, you can just ask him, huh? Biswajit. Uh, so if you find any problem, you can ask them. So, okay. Okay, so I'm ending the meeting right now. So you guys go to the lab and try the program, okay? Thank you.